Mr. Moore's math class!
Good afternoon, guys, and welcome to Mr. Moore's online math class. That's right, guys, we've got plenty to get through today. We're going to learn all about how to find the points of intersection between a quadratic function and a linear function. Now, as you can see, I've brought it to one of my favourite points of intersection here in Moorabah just to teach you all about this lesson today. So let's not wait any longer and let's get stuck straight into the lesson and check out a little animation that I made all about how to find the point of intersection between these two lines. Let's check it out.
So today we're going to have a look at simultaneous quadratic and linear equations. Now let's have a look at this quadratic equation here. We've got y is equal to x squared plus 6x plus 2, and our linear equation y equals 2x plus 2. Now just like we did with the linear functions topic, the reason we use simultaneous equations is to be able to find the points of intersection between two lines. Now these are marked by the yellow dots that you can see on the two functions here. That is where the two lines cross over. Now as you can see, I can change the equation of the linear function by moving the graph down. Now it's y equals 2x plus 1, and now it's y equals 2x minus 1. Now each time you can see the points of intersection between the two lines are changing. And as you can see, the graphs y equals x squared plus 6x plus 2 and y equals 2x minus 2 have only one solution, that is, they only intersect once. And of course, if I continue to move the linear function down, I actually have no solutions, that is, the graphs do not even intersect at all. Alright, so let's go through and have a look at how to find the points of intersection between linear functions and quadratic functions. Now step 1 is to write out both equations. So as you can see, I've written out y equals x squared plus 6x plus 2 as equation 1 and y equals 2x plus 2 as equation 2. Now step 2 says make equation 2 equal to equation 1. Now this is because we've got y on its own for both equations, that is, we can actually use the substitution method. So because we know y is equal to 2x plus 2, we can actually write 2x plus 2 instead of the y in equation 1. So this is what you can see here. Now step 3 says to rearrange and make the left hand side equal to 0. So what I'm going to do is I'm going to subtract 2x plus 2 and take it over to the other side. Of course, when I move it past the equal sign, it becomes the opposite. And step 4 says collect like terms and use a discriminant to determine the number of solutions that there are. So what you can see is I've collected the like terms by making 6x minus 2x equal to 4x and 2 minus 2 is equal to 0. So you end up getting 0 is equal to x squared plus 4x. Going through now and labelling our a, b and c values, you end up getting a is equal to 1, b is equal to 4 and c is equal to 0. And so now that we know our a, b and c values, what we can do is substitute these into the formula for the discriminant. That will get us b squared minus 4ac. So you get 4 squared minus 4 times 1 times 0. 4 squared is 16 and 4 times 1 times 0 is 0. So you get 16 minus 0, which is equal to 16. And of course, because our discriminant is positive, we know that we have two solutions. Now you can actually see that in the two graphs above here, because you can see that they actually cross over twice, as highlighted by the moving arrows. So now that we know that there are actually solutions that exist, what we need to do is go through and find out whereabouts these two lines actually cross over. And to do that, we need to follow step 5, which is to solve for x to find the x coordinates of the points of intersection. So let's go through and do that. So because there's two different types of x, for 0 equals x squared plus 4x, we need to actually factorise in order to be able to solve for x. So this gets us 0 is equal to x times x plus 4 in brackets. And now when you go through and solve each mini equation by making it equal to 0, you get x is equal to 0 or x plus 4 is equal to 0. And rearranging will get us x is equal to 0 or x is equal to negative 4. So we now know our x coordinates of where these two lines cross over, but we don't actually know our y coordinates as highlighted by these two question marks in the Cartesian points here. So now it's time to follow step 6 and substitute the x coordinates into either equation 1 or equation 2 to find out the corresponding y coordinates, that is how high up these two lines cross over. So I'm going to choose to substitute x equals 0 and x equals negative 4 into equation 2. And I've chosen this because there will be less working out involved in simplifying equation 2 than what there will be for equation 1 after I've substituted in. So instead of writing x, I've written 0 and negative 4 in both of the equations. Simplifying now, I get 2 times 0 is 0, plus 2 is 2, so I get y is equal to 2. In the other equation, I get y is equal to 2 times negative 4, which is negative 8, plus 2 is equal to negative 6, so you get y is equal to negative 6. Therefore, with an x coordinate of 0 and a y coordinate of 2, I get a point of intersection at the coordinate 0, 2. And for the other one, with an x coordinate of negative 4 and a y coordinate of negative 6, I get my other point of intersection at the coordinates negative 4, negative 6. Which of course we can now see as it's highlighted on the graph here. Alright, so that's all well and good, but what happens if we have a graph with no points of intersection? That is, they don't actually cross over at all, or something that looks like this. So as you can see, we've got the two functions y equals x squared plus 6x plus 2, and y equals 2x minus 4 now. So step 1 is to write out both equations, so I've done that by writing y equals x squared plus 6x plus 2 and labelling it number 1, and y equals 2x minus 4 and labelling this number 2. And just like before for step 2, we make equation number 2 equal equation number 1. Now we can do this because we've got y on its own for both equations. That is, we can use the substitution method when applying simultaneous equations. So as you can see, we end up getting 2x minus 4 is equal to x squared plus 6x plus 2. Now step 3 says to rearrange and make left hand side equal to 0. So as you can see, I'm moving the 2x minus 4 over to the other side, and as soon as I move it past the equal sign, it becomes a negative 2x plus 4 because the signs swap over. And of course, step 4 says collect like terms and use the discriminant to determine the number of solutions. So collecting like terms, I end up getting x squared plus 4x plus 6 is equal to 0, and my a, b and c values are going to be a is equal to 1, b is equal to 4, and c is equal to 6. Substituting into the discriminant formula now, that is b squared minus 4ac, I end up getting 4 squared minus 4 times 1 times 6 because b is 4, a is 1 and c is 6. 4 squared is equal to 16, and negative 4 times 1 times 6 is equal to negative 24. Now 16 minus 24 is equal to negative 8, and because the discriminant is less than 0, that is it's negative, there are no solutions, as you can see highlighted by the two arrows pointing here because the lines do not cross over. And therefore, because we proved by using the discriminant that there's no solutions that actually exist, that is the lines do not actually cross over, we don't actually have to go through and look for any points of intersection. That makes our life a whole lot easier, as you can imagine.
Alright guys, so now we're going to check out a little bit of an introduction that I've just made on how to find the points of intersection between two equations. This will go through step by step on exactly what you need to do. So let's check that out.
Now as you've just heard, today we're learning all about how to solve simultaneous quadratic and linear equations. Now there's a few steps that we need to follow in order to be able to do this well. Now the first step is to ensure that the linear equation is in the form y equals mx plus c, and that the quadratic equation is in the form y equals ax squared plus bx plus c. So for example, if we had 2x plus 3y equals 6, we need to make sure that we rearrange and make y the subject so that we can then solve these two equations. Now step 2 is to make the linear equation equal the quadratic equation. Now this is much like the substitution method that we covered back in chapter 1, that is linear equations, for solving simultaneous equations. Now step 3 is to rearrange both sides to get all terms on one side and make the other side equal to 0. Now this will actually in fact make a new quadratic equation. Now step 4 is to use the discriminant to tell us how many solutions we're going to have. Now remember, the discriminant is equal to b squared minus 4ac. Now if the discriminant is greater than 0, we'll actually have two solutions. Now unlike what we've done before where we actually found the number of x-intercepts that it has if it has two solutions, etc., because we've used simultaneous equations, what this is going to tell us is the number of times the two equations actually intersect together. That is, how many times the quadratic equation and the linear equation intersect together. So if the discriminant is greater than 0, it's going to intersect twice. And if the discriminant is equal to 0, well then the quadratic equation and the linear equation will intersect just once. That is, it's called a tangent. And of course, if the discriminant is less than 0, the quadratic equation and the linear equation will actually not touch at all. That is, you'll get something that looks like that. Now step 5 is to go through and solve for x. Now remember to factorize if you've got two different types of x, as an x squared and an x. Now once you've got this x coordinate, what you can do is you can substitute that back into either one of the functions and find the y coordinate. Now this will actually tell you the point of intersection. That is, if you come back down here and have a look at these graphs that you can see here, it'll actually tell us whereabouts these two functions cross over, such as in the first one or in the second one. Now of course, if the discriminant was less than 0, then you wouldn't go through and do this because you know there's no solutions at all. And step 6 is to go through and find all the points of interest for both functions. That is, the x-intercepts by making y equal to 0, the y-intercept by making the x equal to 0, and of course the turning points of the quadratic. And finally, step 7 is to sketch the graphs of both functions, remembering to show all points of interest. That is, once again, the x-intercepts, the y-intercepts, the turning points, and whereabouts the two lines cross over.